You got one? Go ahead, Sean. Nick. And if things have parentheses, use phrases like the quantity of, because there's a lot of parentheses in this homework, I notice. Give me section and number.
Section 4.8.
Okay.
Number 4.
What do you got?
I don't know. It's a word problem. I believe it.
I need the wording, or else I can grab a textbook real quick. Sean, you got it?
Yes. It's
Nice and loud.
the squares of two consecutive odd integers equals 130.
The sum of the squares.
Yes.
The sum of the squares of two consecutive odd integers equals 130?
Yes.
Well, that's the easier way to write it, but they wrote it like a more confusing. Like, so I think Sean translated
You're
it
translating
in
it?
a way, but actually
Let's
it's
read
kind
the
of-
exact
I
wording.
have it.
Two consecutive odd.
You have the exact, is that it?
Yeah.
Find the two consecutive odd integers, the sum of whose squares is 130.
Yeah, okay. Find the two consecutive odd integers, the sum of whose squares. The sum, so we start with this. The sum of whose squares, those are each going to be squared, is equal to 130. And if they're consecutive odd integers, what do I put in those placeholders? Gus? Yeah. And then solve.
I added them before it, and then I squared it.
Yeah. So, it becomes x squared plus x squared plus 4x plus 4 equals 130. Remember, the right side has to be FOILed, obviously.
Wait,
And then collect terms.
Mr. Hell?
Yeah.
Will you take off for the equals 0 carrying down on the problem set because we didn't have prior knowledge of that before you did it?
Honestly, Lola's going to agree with that. And she didn't take off for the 0 on your quiz. I was the one who took off for the 0. So she's probably not. And I'll tell her not to for now. But on a test, you need to make sure it says equals 0. Yes. Is that okay to stop there, or do you have to go further?
I just like to see the answer.
All right. Just because?
Yeah.
9 by 7, I guess, right? Hey, by the way, that's something I should point out. Some of you are using AC method for problems that don't involve a 2 as a coefficient. There's no need, right? Remember, look, take a look real quick, because this is more than one person did this. What numbers multiply to give me negative 63 and add up to give me a positive 2? Remember, you do not need AC method for this problem here. You don't have to even use grouping. Some of you are using grouping and splitting up the middle term. Okay, so we're literally just putting the values in like this. We go directly to this part. And I need a positive 2, so that's a positive 9. A negative 7, 9 times 7 is 63. So the answers are going to be 7 and negative 9. And did it say they were positive integers or just integers? Just integers? So that's one. So one of my answers is negative 9, one is 7, making the next consecutive integer negative 7. So that's one answer set. Making this next consecutive integer positive 9, that's the other answer set. So I take my answer and I yield the next one by adding 2 to it to get the next consecutive. If you did x minus 2 instead of x plus 2, it works also. But then your answer for x, you have to take away 2 to get the other integer afterward. Clark?
You can, since it's like 2 times x plus 9, you can just divide out the 2 because there's a 0 on the other side, right? That's where the 2 goes.
So I took out the 2 back here at this point, right? In this time, right?
Yeah, but then it's still on the left.
Yeah, so remember the rule is that you make a t-chart?
Yeah.
So when I make a t-chart, I have 3 factors. Can 2 equal 0?
No.
So it's a contradiction. So you get no solution from that factor.
Yeah.
So that factor does not play a role. Now, if that factor had an x next to it and it were 2x, when is 2x equal to 0? If x is equal to 0. So then it does matter if it's a factor that comes out as a variable. Okay? Gus? Hold on. Any questions on this problem? Any more on this problem? Go ahead, Gus. Sorry. Section 4.7, number 48. Can you read it carefully?
Yes. Function f of s equals 4x squared minus 17s squared plus 4, and then it's set on the zeros.
It's 4s before.
Thank you. And then it says find the zeros of the function. All right. So something like this, first of all, zeros of the function are when you set the function equal to?
0.
Yeah. Right, we see that? Is that obvious right now? Good. I hope we're all paying attention and not doing other stuff, right? We're all paying attention. I see some taking notes, I see others not taking notes. I should see writing, right? A pencil, writing of some sort. You should not be typing anything right now whatsoever. So I have 4s to the fourth minus 17s squared plus 4. The key to this problem, Gus, is that when you have something to the fourth power, it's really just s squared in both cases. That's what it is. But now we have to figure out, is it going to be a 4 there? Is it going to be 2 and 2? You follow what I'm saying? But the key is to treat this like any other AC method problem. So still use AC method the same way. Now, if the ends are perfect squares, I could also think, can I take the square root of these? Well, that gives me 2 times 2 is 4, times 2 is 8. The middle term is an 8, so that doesn't work, that method, right? So for these problems, I would still use AC method, but I would recognize that my factors are going to have s squared terms instead. So what does AC method yield in this problem? 4 times 4 is 16, right? What numbers multiply to 16 and add up to negative 17, Gus? What multiplies to 16 and adds up to negative 17?
Oh, negative 16.
Negative 16 and negative 1. So I could look at all the factors of this, 1 and 16, 2 and 8, or 4 and 4. The only way to get 17 is to add these two together as both negatives. So I rewrite my equation as a negative 16s squared minus 1s squared plus 4. I then factor out using grouping. Out of here comes a 4s squared, leaving behind s squared minus 4. What do I take out of the right term, though?
Negative 1.
Negative 1. Because, remember, whatever is here has to also end up over here. And right now, I don't have s squared minus 4. I have negative s squared plus 4. So I need to take a negative 1 out of the right-hand side of this equation. And that leaves me behind with s squared minus 4. Now that s squared minus 4 is in both terms, I could factor it out in front. When s squared minus 4 comes out of here, I think of it this way. Ready? Take a look at what I'm doing, please. When I take s squared minus 4 out, I think of it as if I'm crossing this out. Right? I'm literally taking it out of both terms, leaving me behind with 4s squared minus 1, which comes from this piece and this piece together. And then finally, what's my last step? This is an example of, Andrew? Before that, Clark? Difference of squares. Right? Isn't that what this becomes? And then this one becomes...
Mr. Howell, would it also be acceptable if we just kept it in the squared form, just took the square root under the t-chart?
And then you put plus or minus on your answer? Yes, as long as you do that, though. On the quiz, many forgot plus or minus with s squared minus 25. Okay? So you don't technically have to factor. If you set s squared minus 4 equal to 0, and you add 4 over and take the square root, it's fine, but it's plus or minus. I personally factor all the way completely through every time. Doesn't matter. Okay? Those are my 4 answers. Notice I annoyingly carry down equals 0 every time. Okay? I'll tell you. Any more on this one? Any questions on this? Good.
I got s squared minus 4 times 4s squared minus 1. But do you have to do the difference of two squares? Because I still got the same answer.
You just asked this question. We just went over it. All right. He just asked the exact same question. You got to listen to others. So you don't have to is what I answered. I said you don't. You can take this line right here and you could say, well, you know what? S squared minus 4 equals 0 works, right? And that becomes s squared equals 4. So s equals plus or minus 2. And that's where these two answers come from. And then I could do the same thing with this factor. And that's where these two answers come from right here. Okay? So you don't have to is the answer. And you get the same answer. But you need to remember to do plus or minus when you take a square root. Because the square root of 25 is not just 5. It's plus or minus 5. Okay? All right. On to the next one. Altea, go ahead.
Yeah, it's one.
What was it?
8 from 15.
Can you read the whole thing? Is that possible, or should I actually look?
I'm looking at it.
You got it, Bridget? Go ahead.
Projectiles launched upward from ground level with an initial speed of 98 meters per second. How high will it go with the moment of reach returns to the ground?
How high does it go is your problem? Okay, that's fine. So if you want to know the max height, when will the max height occur is my first question for you. When?
Halfway up.
Yep, halfway through the total time.
Yeah.
So the key here is, I'll tell you, set the height equal to 0 first and find the time it takes to come back to the ground. And once you get the time it takes at the end, take half of that number and to get the height at the max, go ahead and plug in the time it takes to get halfway there, and you'll get some number. So you made a mistake. So the idea again is to start by setting the height function equal to 0. Solve this to get the t at the end. What did you get for your time?
20.
Did everybody else get 20 seconds for the total flight? So then you take 10 seconds and you plug 10 back into the height function. Yes? You use the initial velocity of 98, and what do you get for your max height?
490 meters.
You're not getting 490? Is that the issue?
Maybe she put it as 10 equals negative 4.9 t squared plus 98t instead of h of 10.
So we're doing h of 10, and the formula is negative 4.9 t squared plus
98t.
98t. So remember, I'll tell you, t goes in here and in here. So take a look at your math. It must have been an arithmetic mistake when you typed in your calculator.
Accidentally said minus 98.
There you go. Okay, that's all it is. So, but that's a good question to ask. Definitely a good question for the test. You remember how I always give you like 3 or 4 word problems? We have geometry, right? We have the integer word problems. We have the height word problems. Those are the main 3. Geometry, integer problems, height word problems are the ones that we're going to expect for the test. I could throw in a 4th that's something different out of the word problems, but I usually say choose 3 or 4. So you're more than capable of doing at least 3 right now. Questions about this problem? Yes?
I mean, it's more of just like, what threw me off with this one is that it asked for the height, like the max
First.
height first. So I started doing that first, and I was like, I can't figure this out.
And there is a way to do it, but we haven't gotten to quadratics yet. You could use the equation for the axis of symmetry. And with the axis of symmetry, you could figure out the midpoint of the parabola. And that'll give you the exact middle time. And the axis of symmetry is like the average of 0 and 20. And the answer we used was 10 for the time. So if you use the axis of symmetry, you'll also get 10. And then you can plug that in. So that's acceptable if you want to. But it's not, prior knowledge is not assumed, so I don't make an assumption there. Nick?
When you want it, when you set it up equal to 0, would you have it as like the problem for meters for like how can I put meters in that equal to 0?
Right there in blue. See
I
what-
couldn't like find the answer.
See what's in blue there?
Yeah.
So if you factor out a t, right? Factor t out of here, you're left with negative 4.9t plus 98. And then one of these is t equals 0. And then if you solve this guy over here, you get t equals 20. And it's the average of those 2 times is the max height time. You see what I did?
Yeah.
I said each factor equal to 0. Why is t equals 0 one of your answers? Because at time equals 0, where is the object? On the ground. And after 20 seconds, where is the object? On the ground. So at 10 seconds, it's halfway up. It's halfway through its flight at the max height.
I have a question. If the original equation has 98t as positive, then the time would be a negative.
No. Do it. It's negative 4.9t plus 98. Move 98 over as a negative 98, and then divide negative 98 divided by negative 4.9. You get a positive time. Do it by hand, I'll tell you. You're just seeing something mentally a little bit there. You know what I mean? You're not seeing a little spot. Just do it by hand. Set that factor equal to 0 and solve. It is absolutely positive 20. You're just missing a negative sign in there.
I was going to ask you another question.
Any more questions on this problem?
Well, it's not a question, just you can actually take the negative 4.9
Yep.
out when you get to it.
Yeah. If you factored out negative 4.9t instead of just t, you get negative 4.9t equals 0, and then you get t minus 20 equals 0, and you could solve that as well. 4.9 is your GCF actually here as well. I just didn't even say it because it doesn't matter in the end. But yes, you're absolutely right, Lil. Good point. Very good point. Gus, next question. I'll tell you, yeah? You got it now?
Oh yeah, I forgot the negative and the divide.
It's fine. Yep, but you see what I mean? It's just a small thing. Gus, go ahead.
Number 2146.
Hey, by the way, tell Jimmy and Nick that I'm going to post this video, obviously, for the review, so they should review it tonight, okay? 4621, what do you got? What's the problem?
U squared minus 8b minus 12b squared.
Equals?
0 is fine. 0. It's just factor.
It's not an equation, it just says the factor? Thank you.
Yeah. Is this a prime polynomial? Yeah.
Is it prime? Does it work out to be prime?
Yeah. I looked at, I saw them.
Let's take a look. Square root of this is u. Square root of this is 2v.
No, it's 12.
Sorry,
Say
what?
4?
Yeah, it's negative 12.
Yeah.
There is 12, my bad. My mistake.
That's okay. Right here is 12. All right, so but either way, let's make believe it could be, okay? I want to show you something. So, in all of these problems that involve another variable linear and quadratic here, make believe they're not there and try to factor without it. And if it can be factored, just tack on the v in the second part of your binomial. So if this could be factored, hypothetically, it'd be this, right? Like that. And then you'd put a number. It's not right. This is not right. Say it became this. Say hypothetically that was it. You just tack on a v here and here if you have the extra v squared there.
If it's factor.
If it's factorable.
And this
But
is not. This is from.
can any numbers multiply to give me negative 12 and add up to negative 8? So 12 is 1 and 12, 2 and 6, 4 and 3. And they have to have opposite signs. Even if I add these, I get 7. If I have opposite signs, I get a 1. If I add these, I get 8. But again, they have to have opposite signs. So if I add 6 and negative 2, I get 4. Or 2 and negative 6, I get negative 4. So that doesn't work. And then if I add these, 1 and negative 12 gives me a negative 11. Or negative 1 and positive 12 gives me positive 11. So none of these in any combination add up to give me negative 8. So it is prime. Okay? But I want you to see, Gus, that the v squared at the end and the v in the middle doesn't affect my factoring. You just have to tack it on to the second part of the binomial. So let's do one that does work, okay? Ready? Let's say, and let's tack on the y at the end here. So the same type of problem that we just looked at, but now it is factorable. Treat it as if the y squared term is not there at all. So what would this factor into without the y squared, Gus?
X plus, wait. Yeah, x plus 7, and then x minus 2.
Very good.
And you tack on the y at the end of the 7.
So literally just put the y there and the y there, and that's it. Okay? Very good. Good question to ask. Comes up a lot, right? We have multiple variables to factor.
Instead of prime, could you say could not be factored?
Yeah, fine. Absolutely. And that's by definition what prime means. A prime number is like a number like 3, cannot be factored into integer coefficients, integer factors. Yeah, go for it.
49, number 26.
Can you read it?
Yeah, x to the fourth power minus 18 is less than 7x squared. I'm confused.
1 on 36?
26. 26. So in all of these problems, we have to always set it equal to. And in this case, it's less than 0. We're going to set it, right? So I move the 7x squared over first. So far, so good. Factor, critical points.
Actually, 36.
So because
Except for parentheses,
T minus 9.
we're going to get to that, yeah. But let's factor it first like this, right? So what multiplies to give me negative 18 and adds up to negative 7?
Plus 52, negative 9.
Therefore, this factors further into x plus 3, x minus 3. Unfortunately, does this one factor any further? No. Remember, x squared plus some number is not factorable. It's also not going to give us real roots because we're going to get the square root of a negative number. So on our number line, we just don't account for it as a critical point. That's it. Yeah, you don't account for it. So set this equal to 0. Set this equal to 0. Set this equal to 0. Remember, I'm finding my critical points, not my solutions, because this is not an equation, yet it's an inequality. This works. This works. So there's 2 critical points. But if I do this, I get the following. And then if I do this, I get... And we have not done things with imaginary numbers yet. Even if we did, it wouldn't affect the answer. You don't plot imaginary numbers on a real number line. The number line that we use to test is the real number line. This answer is imaginary. We do not use it as a critical point, and therefore we only have 2 regions. Can somebody tell me how it works, please? What do we get as our things? Plus, minus, plus, minus, plus, minus. What is it? Plus, minus, plus. And we want to know, when is this function negative? Only in the middle region. Open circle on my critical points because it's just the less than symbol. Shade in between. So my solution set says the following. Okay, remember, what am I doing in this problem? I'm going from my critical points right here to the number line, and then from the number line to the solution set itself. Okay, I kind of did that in a weird order. Okay? Yeah. What? Yeah, either one of you guys. I saw your hand up first, Andrew.
I was going to ask where you're about.
Sure, go for it. Is it a question on this right now?
Yeah.
Yeah, go.
So I was a little confused with this. I thought you pointed the arrows where the positive is.
Well, it depends on what the statement is. See the circled statement in red? Mm-hmm. So you look at the polynomial. When is the polynomial less than 0? When the region is? What numbers are less than 0? What kind of numbers?
Negative numbers.
So when the region is negative, that's the region we want.
Okay.
So when we test the regions, we just test...
The other way around, you put the positive.
Correct. If it was a greater than symbol, it'd be the positive regions you would shade. Now, open circle because it just says less than. If it said less than or equal to, those 3 and negative 3 be closed circles, both. Yeah? Okay. Anything else on this question? On this question?
So you say you found like the leftmost region first, like and then plus. Could you then assume like the next one's negative and then
Because the minute we have double roots, it's not true. So if you remember that for double and triple roots, that's not true, that's fine. But if you apply it to all things, Olivia, you could run into that issue. So if you want to remember both things, that's fine, yeah? John?
I have a question.
Yep, anything else in this? Okay, go for it, John.
It's 4.9, 16. And it says x squared plus 9 is less than or equal to 6x. I just want to make sure.
Yep. Can I just go through it and just watch?
Yeah.
Okay. Because it's a double root, it only occurs once on the number line. If I test the region to the right, I get positive. If I test the region to the left, I get positive. We're squaring, so squaring 2 numbers should always be positive, I think, right?
Yeah. But regardless, you don't.
So the idea is that we want to know, when is this number less than or equal to 0? It's equal to 0 at 3. Right? When you plug a 3 in, take a look. Plug a 3 in here or plug a 3 in here. The value is equal to 0, right? Mm-hmm. But is it ever going to be less than 0? So what's my answer?
X is equal to 3.
Yep. There's no solution set. It's a solution value in this case. Althea? No. Try any number, square it. What do you get? Any number. Forget this problem. Any number squared is always... Yeah. And isn't this right here saying, take a number, right, between these two here, take a number and square it. That's what it means when you multiply by itself. So if you ever get anything that says x plus 2 squared, x plus 7 squared, x minus 5 squared, the regions are always going to be positive every time. And the graph of this, just for those that like the graph looks like this. There's my parabola. And it's always above the x-axis. The y values are always positive. Remember, the number line, let me point to this right here if you need help with this. These symbols right here and here, right, these two symbols, those things are telling me about the graph. They're saying the y values on the graph are always positive in these regions. And that's shown over here. Oops. That's shown over here in these two regions with both positive branches. Questions on this example or something like this? Okay, next. This is good. This is great, guys. Keep asking questions. Go ahead.
I just want to make sure for 4824.
Word problem?
Yeah. I have a sort of shortened version of it.
Okay.
It's a farmer builds a wall. The perimeter is 21 meters. The fence is only on 3 sides.
Okay.
The area is 55 meters squared. Find the dimensions.
Perimeter's 21, area is 55, only 3 fences, right?
Yes.
Okay. So I start by labeling X, X, and then Y. We're not told that it's a square. We're told that it's rectangular. So we know we have 2 of 1 dimension. Does it matter if I call it 2Y and 1X? Does it matter? No. They're placeholders. I do know that perimeter is the total length of fence. So 2X plus Y is going to be 21. And then XY is the area, and that's going to be 55. So that's my setting to start. Anybody have questions so far about what I started with? Perimeter is equal to the length of fence, and that is X plus Y. That's why it's 21. Now, this problem is all about substitution method. Solve the first equation always. It's a lot easier. Solve for whatever's already isolated without a coefficient. So 21 minus 2x is y. Take that and plug it in for y right here. This then becomes x times 21 minus 2x equal to 55, and then go through the process of solving. Let me know if you're good at some point, if I should stop, or if I should keep going.
I'm fine now.
You're good at this point?
Sure it was like a system of
Then
equations with
then it says 2 answers, correct?
It does, yeah.
5 by 11 and 5 by 5 by 10.
It probably works, because let's think, ready? If this is 11, 5, and 5, that works, right? And then the other case is?
Yeah, 5 by 5 by 10. No, 5.5 by 10.
5.5 over here. No.
No, 5.5 and 5 is, and then 10. So 10 is the
I just-
y.
I just
5.5.
Yeah, that works. 5.5, 5.5, and 10. That's going to be 11 and 10 is 21, and that gives you... You see how I'm doing mental checks for area and perimeter, right? You see what I did? Right? 11 times 5 gives me 55. 11 plus 5 gives me 21. Always do mental checks at the end. For geometry problems, do mental checks. To solve it, yeah. It's going to be AC method. I would personally move it over to the right-hand side so that 2x squared is positive. Move the 21x over as a negative. 55 is still there already as a positive. I would then use AC method. What do I get? What numbers multiply to 110 and add up to negative 21? Negative 11 and negative 10. Yep, that works. Multiply them, I get 110. Add them up, I get negative 21. I then factor by grouping. X comes out of here. 2x minus 11. Negative 5 comes out of here. 2x minus 11. Nick, am I good at this point or what?
Yeah, you're good.
Okay. So we get x equals 5 and x equals 5.5. Yep, very good. And those are my 2x values we had earlier.
It was kind of weird getting 2 answers for
It is kind of weird, actually. That's a really good question he asked. You know what? The problem might say in the future, find the integer dimensions that could represent this.
Yeah.
So you would reject the 5.5 then. That's the only thing I could see as like a SAT problem where only one answer works out of the two. Julian?
Sorry, could you just go over that, the last part of that?
Yeah. So when I solve this at the end, can you still see?
Yeah.
I get x equals 5, and in this case I get x equals 5.5. And the only way area will give me 55 is if y is equal to 11 here, or in this case if y is equal to 10. Because the product of these gives me 55, but the product of these also gives me 55. So there's two options for my answers here. 5 by 11 barn or 5.5 by 10 barn, where the 11 and the 10 only occur once as a fence. The 5.5 occurs twice, or the 5 occurs twice.
I have a question on 4.5.
Anything else on this one? Okay, go.
Number 12, it's 16x squared plus 40xy plus 25, or 40.
There's like a rule for this one.
Yep. Plus what?
Plus 25y squared.
Equals 0, or is it just a factor?
Yeah, just that.
Is this section 4.5? 4.5?
Yeah.
Okay. So this one is one of those rules where when you get stuck, look at the end terms if they're perfect squares. First, GCF. Is there GCF anywhere?
No.
No GCF. But always look for GCF first, because that could happen. If the ends are perfect squares, think about what their square roots are.
Well, when you multiply them together, they get 400.
Careful. When you multiply them together, these two together gives me 20xy.
Oh, that's what you do. I think you multiply them together to see.
And then if you double this and you get the middle term, it means that it does work, that those are my answers. So if that works, that when you double this, you get the middle term, which is true here, it means that 4x and 5y are all I need here. And then it's going to be squared. And then, Andrew, I take the middle coefficient, since it's positive, and I put a positive right there. Did you see what I did at the end?
Yeah.
Okay, I recognize that the 40xy is positive, so that's why my sign is positive in the middle.
Okay.
And that's my answer.
Alright.
Okay? If the square roots of the n terms, their product doubled gives you the middle term, this works, this technique. I never learned this technique in high school, honestly, I never did. And I always did AC method. It works if you do AC method, but it's just messy. Okay, it works, but it's messy. Doing well. We got 8 minutes still. Yep, John, go for it.
Can we go over problem 16 and 4.9?
What do you got?
4x parentheses x plus 1 is greater than or equal to 3.
So I have to make it equal to 0 or greater than or equal to 0, so I automatically start by distribution. I can at the same time move the 3 over, and therefore I got this. Good so far? Okay. Now at this point, what method do I use?
AC.
I would use AC here. I mean, you could try 4x and x, and you could try 2x and x, and that works, but I don't like to. What multiplies to negative 12 and adds up to positive 4?
6 and negative 2.
Looks good to me. Factor out GCF. 2x comes out of here first. Leave me with 2x plus 3. Take a negative 1 out. Leave me with 2x plus 3. Take the 2x plus 3 out. Leave me behind with 2x minus 1. John, let me know when I'm good. My critical points become negative 1.5 and 0.5.
You're good.
I'm good? Okay. What is my anybody need me to finish this? Anybody want me to finish this? I'll tell you, yeah? Okay. So I make those my critical points on my number line. Since it's greater than or equal to, I shade those circles in. They're closed circles. I then test my regions. By the way, we always do this. What is the easiest number to test always, or the easiest two numbers to test?
0,
And
1.
1. By far the easiest numbers to test. So where, by the way, I talked about it in the video, but I didn't talk about it in class yet. What line of code, what line of the process do I test my point in? It's really important. It's a lot easier if you do this. The factored form. If you haven't been doing that, I mentioned in the video for homework when you listen, but in case you forgot, please test your value here where I'm pointing right now. So when I test the 0 in here, it makes it easier. Look, this drops off and this drops off. It becomes 3 times negative 1. It's just a negative number, isn't it? So test 0 in the factored form. This becomes a negative region. positive region, positive region. I want to know, when is this greater than or equal to 0? That's positive regions. So I shade the positive regions. And my answer becomes an or statement. X is less than or equal to negative 1.5, or X is greater than or equal to 0.5. Graphically, to see this, here's 0.5, here's negative 1.5, and here's my graph. When are the branches greater than 0, meaning when are they above the x-axis? Shaded in blue. Shaded in blue. Okay, and again, I'm shading outward on the graph. I'm also shading outward on the number line. They always correspond to each other.
I just want to make sure it's okay if I got like fractions.
Yep.
X equals 1
Yep.
half and negative
3 halves and 1 half? Yeah, absolutely. Yep. And I personally would leave it in fractions half the time. I just put decimals to make the numbers reasonable on the number line. I don't know. Doesn't matter. Others. Other questions in general. Question test. Questions about stuff. I don't know. I'm trying to think of what else you guys want to ask. Yeah?
It's the same format.
Yeah. Definitely multiple choice. Definitely short answer problems and definitely word problems. I mean, the short answer, what do you expect them to be? What kind of problems, honestly? The short answer in the middle, not the word problems. It's going to be factoring. It's pretty much going to be all factoring, right? That's what this test is all about. So short answer, you could be factoring expressions. You could be factoring parts of equations to get the roots. You could be using factoring when you set a function equal to 0 to find the zeros of a function. You could be factoring to find the x-intercepts, which are the same thing as the zeros of the function. So if I ask you to find the x-intercepts, you're going to set y equal to 0. So you set the function equal to 0. The x-intercepts, the zeros of the function, the solutions to an equation equal to 0 are all the same thing. Same exact process. Anybody want to pick a word problem that we could try to end the day on that we didn't do yet?
Well, I started doing 18.
Number 18 and 4-8.
Sure. Okay, so Lewis wanted to throw an apple to Kim who was on a balcony 40 feet above him, so he tossed it upwards with an initial speed of 56 feet per second. Kim missed it on the way up, but then caught it on the way down. How long is the apple in the air?
So our goal is to find the larger of the two times. We're going to get two answers, right? Think about this problem. When is the apple going to pass 40 feet? How many times? Once on the way up and once on the way down. On the way up, that's going to be a lower time value. So we're going to go ahead and use the equation in feet per second. In feet per second, it's negative 32.2?
Is it negative 16?
16.1, sorry. Do they just use 16 or do they use 16? No, it'll be given. It'll be given on the test. So I have h of t equals negative 16 t squared plus 56t.
So
What?
Be given on the test, but the sum and difference of cubes will not be, right?
Correct. We didn't do any difference in sum of cubes at all today, by the way. No one asked a question about that. So you need to know sum and difference of cube for sure. We can maybe get into it real quick. So this is 40, because the height is 40 when it passes the friend. We then move the 40 over. We then factor out a 4, or a negative 4 I'd factor out. Negative 4 out of 56.
I factored out 8. From
14.
Oh, yeah, you know what? 8 comes out of both, actually. Instead of leaving a 4 here, you're saying? Yeah.
Yeah, so I got 2.
Yeah, let's factor out negative 8. That's the greatest, right? Greatest common factor. Definitely negative 8 instead. So we get a 2 there instead, right? And then a negative 8 out of a positive 56 is a negative 7. And then a negative 8 out of a negative 40 is a positive 5. So this becomes AC method, unfortunately. What do we get for our times here? Oh, we didn't do this. This was just practice, right? Without AC method, can anybody get this one? It's going to be 5 and 1 for sure. Negative 5 here, negative 1 here. Is that going to work? No. Switched. Right? That works. Oops. Right? That'll give me a negative 5. That'll give me a negative 2, which yields negative 7. So that works. So you can do AC method, or you can just try and error it. My two answers I'm going to get then are going to be time equals 5 over 2 and time equals 1. So after 1 second and after 2.5 seconds. So it's on the way up. Time equals 1 second, hits here. It keeps going, comes back around. At this point here, time equals 2.5. That's the answer.
Okay, yeah, see, because I got t equals 9/2 and t equals 1, but then I was confused what to do with them.
Large of the two times. Large of the two times.
Can we do a quick
Yeah. So factor the following. What do I do first? First step.
Then find the cube, so you 2 and 9. 2t and 9.
2t squared, careful. 2t squared.
And 3a.
Very good. So this is A. This is B. I then plug into the formula, which tells me A minus B, A squared plus...
A times B.
It's plus and minus on the bottom, so it follows whichever.
Is that right, though, the form? Is it a 2AB in the middle? Are you sure it's a 2AB, not an AB?
No, so you put the minus on top.
I'm just asking the formula. Is it 2AB in the middle, or is it AB in the middle?
No, it's AB.
It's just AB. Yeah, I don't think it's a 2 there, Nick. And then we take whatever A is and plug it in for A, which is 2t cubed. B goes in here, which is 3A. Then I have 2t cubed. No, 2t squared. 2t squared, sorry. But remember that gets squared plus A times B plus B squared. Just simplify the right one as far as you can, please. You can start moving, that's fine. Okay, office hours after school if you'd like to come for a little bit more help. I think I did that right. See if I made a mistake, please. Check that, please. That looks correct. Thank you, Jen.
Mr. Howard, you know what's funny? You know the pen problem we did? The one with the 3 sides? That was the one that I did when I shadowed here, your class. That
No
was
way. Was it really?
Yeah, because we were doing test review. And I think it was, I shadowed sometime in January.
That makes sense. It's about this time, yeah. It's a classic problem with only 3 sides.
Yeah,
and one is
I think Regina asked it.
Good memory. I remember, but that's...
Well, I mean, I definitely expect you to remember.
Have a good day, guys. I'll see you after school for office hours.
Do you have to memorize that?
You need to memorize this right here. But recognize that for cubes, if you make the sum, it just changes this to a minus. So you don't have to memorize it twice. If you can remember it once, you're good. And look at it. I mean, this is AB. It's just A squared and B squared. And then it's the combination of AB. So it's not actually as hard as it looks to memorize. If you just remember what goes here, it's these two as a product that goes here, right? And this sign is always the opposite of this sign. And this is always positive because it's squared. This is always positive because it's squared.
So basically, it's just a foil. It's like basically one of the you repeat 3 times and one of them's already been foiled. That basically just that.
So we identify that this is A, that's being cubed. Do you see how this works? Does this make sense? 2t squared cubed gives you that. So this is A. This literally, this value goes in here, here, and here. This value, 3a, not the negative, just the 3a, goes in here, here, and here. That's what you're seeing substituted everywhere. And then I evaluate it. Who's your teacher?
This cup.
I'm going to walk you down. Stay with me for a second. It's fine, I'll walk you down. So this is 2t squared, quantity squared. So this is what A was. A was 2t squared, but that has to get squared itself. And then 2t squared is multiplied by the b value, which is 3a. And then this 3a, which is the b value itself, has to get squared, which is where the 9a squared comes from. Practice it tonight, or honestly, you're a very smart person. All you need to do is go to YouTube,